Moving ahead from the yesterday's class, yesterday we have discussed concurrent execution, and yesterday we have seen this serial schedule and T1 followed by the T2, and a serial schedule which will belong to the T2 is followed by the T1, and here we have also discussed the execution of the sequences, and that is done by the schedule, and by default we have the serial schedule. Now, this is the schedule 3 which is determined by the concurrent scheduling. So in this concurrent scheduling, what we have done, we have moved or shifted our control from T1 to T2 and T2 to T1, vice versa, as our required, or we can say as our the set of the task which was not executed. So we have seen this part of the schedule. Now in the schedule 4, we have also discussed the concurrent schedule, but now see, this is the problem we have found over here, the inconsistency of the transaction. So where the transaction is having the inconsistency, not a consistent, then we can say the transaction is not following the acid property. So what is acid property? Atomicity, consistency, isolation, and durability. So this is the problem we have seen with the help of this example. Now, so this is summary, and yesterday we have also started the serializable. So we have the two serializable, conflict and view. So what is the mean of the serializability? The summary I can say this is a process to transform conflict serializable into serializable, and that should be equivalent. So no information should be lost. This is the point we need to keep in mind. And differences we have over here, and type we have started. So first one was the conflict. So for the seeing the conflict, or for the identify the conflict serializability, we have to follow, or we have to use the three different operations. Those are known as the conflicting operations. So we have seen yesterday. Now this was the last exercise. Okay, so this was the last exercise we have seen. From this point, we have another kind of the serializability. That is the view serializability. But before view serializability, I have the example over here. If we have a two schedule of the transactions, then how we can say both schedules belong to the view, because most of the in the most of the view serial, we need to read only the data. So this is the point you need to keep in mind first. But that is required to satisfy the some conditions. Those are the initial read, updated read, and final write. So these are three different conditions that would satisfy the view equivalent. Okay, so first we need to look for the view equivalent, and that is applicable to the view serializability. So see, by taking the example, I can say simple way, we have the schedule 1 or schedule 2, and that is that is the first condition we are seeing over here. First requirement, we can say the initial read. So an initial read of the both schedules must be at the same. So suppose two schedules as one as two we have over here, you can see on the screen. In schedule 1, if a transaction T1 is reading the data item A, and then transition, and then in the as2, the transition T1 should also read A. So both are will be equal. So there will be no issue. How we can say two schedule view equivalent, because a read initial operation in S1 is done in the T1, and then S2 is S2 it is also done by the T1. So that is we can say it is equivalent. So what we are doing in the transition T1, we are reading and then we are writing in transition T2. And in the schedule S2, you can see in the transition T1, we are writing. So before writing, it should be read out. So we are taking the some part of the in between part, we can say. So we are writing something on the A, and then we are reading A. So we can say in the T1 and T2, we have the only single operation. So we can say these both schedule are the equivalent. So definitely this is known as this is an example of the view equivalent, and that is initially read. So we can read the initially from which part we are reading, but we are getting the same sense from the post schedule. So we can say we are having the view schedule. So it is not necessary write operation will not be applicable. It is also possible, but if you are using the write operation, then if you generating the same result or same output from the various schedule, so definitely we have the view. Here I'm just saying something to all. Conflict serializability can be a view serializability, but if there is no guarantee view serializability can be conflict. So this is a point we need to keep in mind, and will see it can be or how it cannot be. So by the taking some example, we will see. So let me move to the next slide. That is the updated view. In this slide, what we have the three different transition T1, T2, T3, and now see in schedule one, if transition T1 is reading writing something over here, so T1 and T2, T3 belong to the schedule as well. In the transition T1, what we are doing, we are writing something to A, and then the transition 2, we are writing something to A again, and then transition T3, we are reading something A. But if we have the schedule as 2, and now what we are doing, we are first what we are doing, we are reading from the, we are writing something on the A from the transition T2, and then we are writing something on the A from the transition T1, and at the last we are reading. So it looks like this is the equivalent, but this is not equivalent. So you can read out over here, two schedules are not B equals, because in S1 T3 is reading A updated by the T2, and in S2, so it is also visible. So now you can see, before reading you are writing something to the, you are writing something. So before reading you are writing something, then we can say it is not readable, because the information is updated. So in the transition T1, T2, T3 followed by the S1 schedule, first we are writing and then writing, so we are updating the writing information, and then we are reading. But what is happening over here in the transition T2, first we are writing, and transition T1, then we are writing. So, and then transition T3, we are again reading information. So this looks like a simple, or we can say similar, but it is not a similar, because what is the sequence we need to keep in mind. So what sequence we have, according to that sequence, we need to take care of the your serializability. So view serializability is not simple to detect or identify, but most of the people are looking for this is a similar, but this is not a similar. Let me clear to all once again. These are the conditions, and I have a different example by which you can understand all these concepts. I have taken the example from the books, and this is the example from the somewhere else I have taken over here. So this kind of the example will get you confusion. So to avoid the confusion, it is better idea to look for the bookish example where we have the good example. So in the above two schedule are not view equal, because S1 in the schedule S1 T3 is reading A updated by the T2, and in S2 T3 is reading A updated by the T1. So what is happening over here? Now you can see. Just let me draw this example first, then you can understand. So what is happening over here? In the first schedule, what we are doing, we are writing. So we have the order T1. This is the point you need to keep in mind. Then we have the T2, we are writing. So the information which is containing by the A, that is updated by the T2. So first it will be updated by the T1, and then it is updated by T2. So the updated information that is to be read by the T3 transaction, that should be updated from the transaction T2. This is a point we need to keep in mind. So the information is passing like this one, T1 to T2, and then T2 to T3. But in the schedule, what we are doing, or what we have seen over here in the transition T1 is just passing the information transition T1. Sorry, T2 is just passing the information to the T1, and then T1 is passing to the information to the T3. So the order we can say, observe here, the order we have the T2, T1, and then T3. So notation will be like this one, and now from this point you can say the information which is coming from the updated information to the T3, that is coming from the T1 instead of the T2. So in the S1, the information, updated information is coming from the T2. But in the S2, updated information is coming from the T1. So that's why we can say it is not a equivalent to the view equivalent. So this is my point. So while updating the information, we can say the both schedules are equal or not. So you need to clear all these points, or you need to read the proper information. What is sequence we have over here? This is initial, so there is no issue. First we are reading the information, then we are writing. And in the transaction T2, first we are writing and reading, so there is no issue because both option will be both information will be managed perfectly. There will be no issue. First we are writing some information, then reading. So in the S1 information, we are reading and writing. So information will be updated finally. And if you're reading from the later on after the T2 transition in the S2, so first information will be updated and read. So there will be equivalent, we can say, because ultimate the age value of the both schedule will be same. But here age value of the A will be updated or may change because we are writing something from the T1 in different value and we are writing something from the T2 in different value. So definitely information may update. So there will be no chance, there will be no chance with the information we are getting the same message. So this is updated. And at the last, we have the final write. Now, in this transition T1, first we are writing something. In the schedule S1, we are reading. So what is the information which is updated by the transition T1? We are reading. So there will be no issue. And before writing anything on the transition T3 on the A data item, we can say it would be updated. Now here, first we are reading the information. So what the information we are reading? It's okay, no problem. So it is updated some information by transaction T2, and then the information is passing to the transaction T1 like this one. So there, I can take this example. I can explain this thing by the simple way. Suppose A we have the value 100 rupees. Okay. So here I am writing something to the A. So I am updating the values of the 100 by 10 rupees. So here the information will be 100 plus 10. Okay, if I read from the transaction T2 over here, so updated information will be read out over here. So information will come 110. If I write something over here, so information will be, suppose I am updating something by 50 rupees. So 110 plus 110 plus 50. So information will be 160. If I doing something over here, so I'm reading some information that is by default value we have over 100. So here 100 value will come, and in the transaction T1 I'm updating 110 rupees, so it will be 110. And in the transaction T3 I'm updating some information by 50 rupees, so it would be 110 plus 50. So value would be 160. So finally we are getting the same value from the both schedules, so we can say it is same. It is same, it means we have the B equivalence are the same. So because the final write operation is updating the information from the transaction T1. So before writing anything, it will read some information. So we are saying, okay, it is okay means it is B equivalence are the same. So there will be no operation. So from the above two schedules, we can say there is a B equivalence we have because final write operation in S1 done by the T3. And in the S2, the fund write operation is also done by the T3, and we are getting the same answer. So we can say we have the view equivalence operations over here. So this is the point we need to justify. So view equivalent is determining like this one. And same phenomena we have to use in the view reliability. So before understanding the view reliability, it is required to understand the view equivalence part. And we know there are three different kinds of equivalence. One is result equivalence, and conflict equivalence. So result equivalence saying to us after applying the transitions information and we are getting the same result. So we have the result equivalence. And the view equivalence is saying to us there will be different properties must be satisfied. Those are the initial read, updated read, and final write. We're talking about the conflict equivalence, so there must be again three different conditions to be satisfied, and we have seen conflict conflict view yesterday, and that to be applied to the conflict serializability. So now we're talking about the view serializability, where we can say here you can see view severability we are applying here in the concurrent executions. So T1 first will read. So suppose we have the A value something XYZ, and that is to be read by over here. So there is no issue. And A is equal to A minus 50. So there will be no issue. Here we are writing something. So this is a consistent state. This is a consistent state, so there will be no issue. And again here in the transaction T5, this is transaction T5. So I'm reading something from the B data item, and I'm updating the B by the minus 10, and then I'm writing. So again we have the consistent state. So keep in mind that if you're talking about the concurrent execution, then it should follow proper isolation, or it should follow something that is required to proper way, we can say consistent. So we have the inconsistency, so finally your information may update it or you can lose the information. And now read B. Here consistency state, I mean to say that over here, suppose you are withdrawing some amount from ATM card, suppose you have the balance 20,000 rupees. And from the 20,000 rupee your balance, you want to withdraw 15,000 rupees, you are withdrawing. No problem. After withdrawing, your amount is not updated so far. Okay. And after the one day you have seen you have also again 20,000 rupees. After withdrawing the 15,000 rupees, your account balance must be 5,000 rupees. So because the information is not updated, because the database is right now into the inconsistent way. And that what happened at the time? You will try to withdraw 50,000 again, then you are able to withdraw. Because your figure and digitized figure is represented by the 20,000 rupees, then you are able to withdraw 50,000 again. So you will get the 30,000 rupees from the 20,000 rupees that is belong to your balance. So definitely it is not possible. Practically it is not possible. Theoretically you can say. So inconsistency state will lose your information, but from the bank side, but you are getting the advantage. So that is not a good solution. So everything we are doing in the concurrent transition or serial scheduling, so that should be completely consistent state. That must follow the consistent part. But concurrent execution basically uses reliability. So we can say at least switching from the one transition to another transition, so we can say the process or the transition process execution will be done by the processor, and each and every transition will be associated with the processor at the same moment. Depend on the what kind of transition. Right now we have the sequence of the transition. So CP will be busy, and CPU duration can be done faster than the serial. So this part we have seen. So here we have the all the transition T1 and T5 in concurrent execution way, but in consistent state wise. So there will be everything will be fine. So there is no issue. So now we are reading something from B because B information was updated, and we are adding something from the B here. So if I'm trying to be updating B, so that could be done without any problem. And finally, we are doing over here. So here, each and every part of the transition T1 and T5 are in a consistent way. So now see, I'm reading something A over here. Yeah, I'm detecting something from the A. I'm writing something A. Yes, same thing I'm having over here. And here I'm doing update some information over here. So if we are getting the same value from the two different schedules. So this is a schedule. Suppose we have the schedule one, and from the other schedule we are getting the same value. So we can say we have the view equivalence from the two schedules. But right now we are talking about the view serializability. The view serializability will be applicable to the concurrent execution. So now you can see over here. Here, all the part from the T1 T5 belong to the consistent state. So there is no issue. So here you can read out some line over here. So we consider a form of the equivalence that is less stringent. Stringent means you can say very hard or tough, or there's some rules. Okay, then conflict equivalence. But here stringent means we have the less rules than the conflict equivalence. So what that like conflict equivalence, but in the conflict we have the some hard rules. Write or retry is not possible, so conflict may occur. So it's based on the only the only the read and write operation of the transaction. Now see, suppose just let me design or let me choose a different color to explain purpose. Here we have the write A and here we have the read B. No conflict is occurring over here. Instead of the read B, suppose we have the write A over here in transaction T5, so definitely conflict is see, conflict operation will be. So now this is a good example to represent the view serializability without any conflict. So here all the operations belong to the non-conflict operations. So now please tell me, everything is clear to so all out. Is it clear to all about the V equivalent and
Yes, sir.
view serializability? Okay. See, for attending the class, you are also required to please understand the each and every fundamental part very carefully. So this is a necessary part. Now, of course, you must have the question, sir. Can we have the conflict over here? Yes, you can have, but right now you don't have. Why? Because both data items are different. If you have the same data item, so conflict will be there. This is a point. This is a very small point we need to keep in mind while learning the each and everything from the database. Okay, so this is my point. So there is no conflict over here. Now, few things I have to take inform the theoretical way. So now I'm just reading the some points over here for the notes purpose. So you can also read along with me. The concept of the view equivalence leads to the uh, concept of the view serializability. So we say that schedule as in the view serializable if it is a view equivalent to the serial schedule. So now see, if I transform if I transform if I transform this schedule, okay, we can say this is this schedule. If I transform this schedule into serial, then schedule, okay, this is a concurrent. I can say write the concurrent schedule. Okay, so this is a concurrent schedule. If I transform this concurrent schedule into the serial schedule, and if we are getting the same result, then we can say we have the view seriality in proper way. So we are not losing any information because there is no confusion. Same thing we have over this point. Figure schedule, we have this diagram. So I'm coming on that diagram. So let us understand some theoretical part. That diagram we have on the next slide. Schedule is view serializable. Indeed, it is a view equivalent to the serial schedule T3, T4, T6. Since the one read queue instruction read the initial value of the queue in both schedules and T6 performs the final write of the queue in the fourth schedule. Now see, in the T3, what we are doing, we are reading the queue, queue is a data item, and T4 we are writing something, and then again we are reading from the queue, we are writing the queue, okay, and then transaction T6 is also writing something over here. So see, since the one read queue instruction read the initial value of the queue in the both schedules, and T6 performs the final write of the queue in the both schedules. So every conflict serializable schedule is also view serializable. This is the key point you have to keep in mind for the examination purpose, especially. Every conflict serializable schedule is also a view serializable, but there are view serializable schedule are not conflict. Conflict will be the view, but reverse part will not be possible. So this is the point you need to keep in mind. So here what we have to observe here in this diagram, in this figure we need to observe something in from the schedule where transition T4 and transition T6 perform the write operation only without having the read queue operations. Now it is should be visible to all. Now, and that's why we can say how transition T4 and T6, this is my point over here, how transition T4 and transition T6 read the information in such a transition. So how read queue data item. Okay, sorry, how to read queue data item in these transition. So at the time, that is a concept we have to keep in mind. That is known as the blind write because what we are reading we don't know. because we are assuming we are reading something and we are writing something. It is just like equivalent to we have not initialized any variable and we try to print. Okay, we have not initialized any variable like 0, 1, 2, 3, but we are trying to print such variable. So what it will print? Garbage value in programming. If you remember the concept like this one, then you are known to this concept. We have not initialized some values in some programming language, then by default it will print the garbage value. So here we are writing something in the queue that is known as the blind write. So we don't know what we have to write. So we are updating something. So in the view serializability we're talking about in the T3, T4, T6 we have the transactions and we are reading and the writing on the T3 there will be no issue. But what we are writing, we are updating some information in the queue and we don't know what information we need to update because we have not used a read operation. Okay, read operation. So it will write on the queue something that is just like the blank. Okay, so some write some short of the things, and that is known as the blind write. So somewhere you will feel this kind of the example, and you can find this kind of example, and that is known as the blind write. So blind write appear in any view serializable, and that is also applicable. Without read properly, if you write something on the such data item, and at the time you are following the blend right, and that could be the part of the view serializable schedule, and that is not conflict serializable. Of course, that could not be not conflict. Why? Because we don't know. Even we don't know what value we have read out. So in transition T4, so here that should be conflict. Here that should be conflict. That should be conflict. But here we don't. According to the rule, that should be conflict. What is happening over here? In transition T4, we have not used a read operation. Then it can't have the conflict due to the blind write. So this is the reason. So something and somewhere into the internet or any kind of the books, standard book, you will find. So there should be the conflict. Of course, I can agree with this point. But here we don't know what is the value which is read by the transition T for T6. So these two transition have the brand write operation, and this is the point you need to keep in mind. And again, this is the example of the view serializable, and it can have the conflict, it cannot have the conflict, but it right now it suppose does not have the conflict. So we can say the conflict serializable can have the view, but reverse part cannot be possible. So this is a view serializable, but there is no guarantee we can have a conflict, but according to rule it should be. But now we have the new idea, new concept in the database or in the transaction management, that is a blend that is also possible. Why? Because transaction T4 T6 is not known or is not using the read operation. Without reading any information, then how you can justify? So we can write. Okay, it is just like equal to this one without purchasing any notebook. And if you're writing something on the notebook then which does not exist, then where you can write? Okay, so the physically you don't have any register and you are writing the something. It is just like equal to you want to make a call to your friend. Okay, you can make, but you don't know the number, no problem. But you don't have the mobile number, then how you can make the phone number? This is my problem. So if you want to make a call your friend, then you can, but without the phone, how you can? Because you don't have the such a device. Same thing I'm talking about
Excuse
over
me,
here.
sir.
Yes, tell me.
So what will be the order in this?
Order will be the T4, T3, T4, then T3, and then T6. Because we are moving from, see, I'm just writing the order: T3, then T4, and then T3 again, and then T6. This would be the order of the transition execution. Okay, this is the order of the transition execution, but we have only the three different transitions. So number of transition we can represent T3, T4, T6. So this is the only the order of the transition, how many transition we are using. But the execution will be like this one: T3, T4, T3, and T6. Now see, I can represent by the line, then you can understand simply. See, on this specific on the time movement, this transition will execute, and on this time movement, this transition will execute. On this moment, the transition this will execute, and the last transition. Now here we can't use the read queue. Suppose. Why? Because these two transaction, the system can't use the simultaneously two different transactions. It can't execute. So this is not possible because other transaction has to wait. Either you can execute a T4 or T6. So either you can write, you can do the write or you can read. So simultaneously two different operations is not possible. So concurrent we can do because one can done and another has to wait. So the concurrent. The parallel or simultaneous is not possible. So this is a point you need to keep in mind. Now is it clear to you?
Sir,
Yes,
this
tell me.
blind write operation can be possible in our real life means bank server.
See, this can be possible, but right now most of the system are smart in our today era. So we are belong to and we are living. So where you are living, that is, if you are trying to avoid the blind rights, so it should be good. This can be happened. I'm taking the real example. Suppose you are withdrawing some amount from your ATM or not withdrawing, you're transferring by the internet banking. You're transferring 10,000 rupees to your another account. Okay, by from your account to your account to the another account. You can do it, no problem. After sometimes your amount is not debited. Okay, but your another account is credited or maybe credited. There may be guarantee. There is no guarantee. Then at the time what is happening over without reading properly how your account is credited, then information will be rolled back. Here we have to keep in mind two important terms before finalizing, that is known as the rollback or commit. Okay, I'm coming on that point. Now see, rollback and commit. See, in transaction T4 we are writing something, but we found that we have not read out any information from the queue. Then it is better idea to roll back some information which has been written on the queue data item. Okay, before finalizing or before committing the data. So it is better idea to use some operations. These are the different operations, that is the actual operation on database. Those are the rollback and commit. See, this is the most are the two important. These are the two different operations which are handled to such kind of the schedule. Suppose unnecessarily you have a credit 5,000 rupees and you will be happy for the day, but it is mistakenly done. So this can be done like a blind write. We have done the blind write because we have not read the information properly and mistakenly it has been done. So we have write something over in your account and that is mistakenly. So we need to, at the time, to overcome such problem, we have the rollback operation into actual database where it is applicable, and then finally we can commit. So final commit, then your database will be updated. This is the two different operations, and these are the two different command itself in the MySQL as well as the Oracle. So it is also possible. So everything is possible in today's era, but now in today's era where we are living, if we're not talking about the 40 or 30 years back, so blind rate is basically internally managed automatically by the database. So it is not a user requirement. So it is managed by the system only. Yes, now tell me.
Sir, I have another doubt. Sir, if we have a 3 to 4 blind write operation, so sir, all these blind write operations will happen in one pair or different pairs?
No. See once again. In transition T3, you are first reading queue. You are reading. Then you are moving to a transition T4. So in the transition T3, you are reading. No issue. In transition T4, you are writing something. But my dear, without initialize any variable, then how you can use such variable? This is my point in the programming's view. And in the database, without reading the database, just like if you have not created a table and then you are using select star from the XYZ and this XY table does not exist, then how you can read? So this is my point. So without
Sir, I am
reading,
asking.
yes, without reading any information, how you can write the some information on such table. So suppose we have a table XYZ and we have the exist table, but we are not using any table. Just insert into table name. So I'm not putting table name. Then Okay, if I'm putting something on inside into table name and the table does not exist, then it is possible to use something? No. Like this is like just a simple example. Without opening a bottle, without opening the cap of the bottle, and you're just trying to have a sip of water, then it is possible or not? First, you're required to open the cap of the bottle, and that is we are reading. This is my point. And at the time, such thing is known as the blind write. We are writing something. There would be operation that is right operation, but that is a blind. Yes, now tell me.
So, sir, in the third step, when we write Q without don't know what is a means, sir, we don't know what is really Q. We don't perform the read operation in third step, and we writing the Q.
In the T3 operation, in the T3 transaction, there will be no issue because we have already read out the value of the Q. So it is also perfect. There will be no issue. There will be no issue. But
Sir,
in the
is blind right
It
means hello? Sir,
means, sir,
is
yes,
it
blind
all
right means
can be
we
in
are
one pair.
yes. What is mean by the blind right?
sir, is blind right
Means,
means
sir, it
we are writing before reading.
Yes, we are writing before anything into the transaction. Into T4, we have not used a read operation of the queue. Then how you can write on the queue? This is a problem. So that is known as the blind write. We are writing something on the queue. We are writing something on the queue data item before without reading on the without reading by the such transaction. So
Yes, sir,
here
we should write first.
yes, we are
In first.
writing something. So
Yes, sir.
that's why I'm taking this is just a simple example. Without opening door, you're just trying to enter such door. Then it is possible or not? No, this is not possible.
Yes, sir.
So yeah, you can communicate with your friends. Oh, okay, I've entered the my room. I have entered the my room. Now I am in the my room, so I am able to see my table. But my dear, you are not entered to the room. This is the point. So virtually you can say. So at the time here we can say this is we have the blind write operation. And this can be sort out the practically way by the rollback or commit command. Of course, it is also possible. And this can be done in the real example, it is also possible. Now, is it clear to write down this blind write system?
Yes, sir.
Okay, so I'm just moving to the my next part, and see this is theoretical part, and you have to keep in mind. And from this point, it is required to understand the why concurrency control is required. So I'm reading some points over here, and you have to keep in mind. And for notes purpose, and I'm not giving the 100% surety of the TW examination, but this point you need to keep in mind for the TW examination. Implementation of the isolation, no practical part over here, only theoretical part.
Sir,
And
this is separate topic, no? Or
no,
this is
no, this is a separate top. This is a separate topic, but it is a based on the previous concept, that is the view and conflict serializability. We have the sequence. We have the sequence. Okay. So far what we have seen the serializability, schedule, and view serializability. Now this implementation of isolation is saying to us, are we performing or are we getting the right isolation or getting the actual isolation and property? So far we have seen. So far what we have seen, we have discussed some properties of the schedule, and those are the schedule or serializability, and followed by the conflict and view. But really, are we following the isolation? No. How you can say? Of course, in the concurrent execution we have the inconsistent state, and due to this inconsistent state we are not following the proper isolation. And this is the my point. Now isolation is saying to us, if we have the a value, suppose 110 rupees, and b values we have the 20 rupees, and if I'm transferring 5 rupees to the B, so it will be deducted by the 5 rupees from here, and B will be added by the 5. But after deducting some amount over here, but I did not update, or I did not use the right operation on the data item A, then A value will be as it is. Before using this one. So if I try to read a value after detecting some operation, so at the time that part belongs to the inconsistent state. So what is happening over here? So what is happening over here? A value is as it is preserved. So there will be no change into the A value. But see, in the B, what I have done, I have added the 5 rupees and read B, add the 5 rupees to the B's data item and perform the right operation. So here B's account is credited by the 5 rupees, but A's amount is not, A balance is not detected. So this is the scenario where we can say transition is successfully, but that is transition belong to the inconsistent state. And but in the isolation, it should not be followed. In isolation is saying to us, if you are performing the one transition and that is related to the another transition, then there should be consistency between the both transaction, and both transaction must have the consistent database. So this is the point. So far you can say you must have, if it is to leave the database inconsistent and allow the transition failure. So finally, that is to be updated, but that is to be not updated A. So transition is not successfully properly. Transition is done successfully, but that is not actually successful. It was failure. So this is the problem. So to avoid the such thing, we have the concurrency control. So implementation of the isolation is saying to us, if you really want to implement the isolation in proper way, then you have to use an important concept that is known as the concurrency control. And now see concurrency, what is the mean by the concurrency we have seen, and that concurrency must be controlled, and what is the thing by which we can control. So that is to be implemented and enter into the concurrency control schemes or concurrency protocol. Now see this one. So this is the next topic which saying to us, if you want to control the concurrency, it means you are talking about the maintain the property of the isolation. Acid consistency, or it is okay, durability is okay. But if you're talking about the isolation, just like I'm taking the same another example for you now. Your friend is just want to send 200 rupees to you. Okay, no problem. After the 5 days, your request to your friend, okay, just send me the 200 rupees, then no problem. He just grant your request and he sent you, or he just ready to send you 200 rupees. He sent you 200 rupees. But suddenly, what happened? You received the 200 rupees and you will be happy. But your friend account is not deducted. Your friend balance amount is not deducted by 200 rupees, but your amount is credited by 200 rupees. So this is what, this is the, we have the point that is belong to the consistent state or inconsistent state. At a time your friend's database or information belong to the inconsistent. Now that should not be followed. Say vice versa, you can take it. Your friend account is deducted by the 200 rupees, but your amount is not credited by the 200 rupees. Then you will call your friend. अरे भाई अब तो पैसा नहीं भेजा, 200 रुपये कम पड़ गए. Now what is happening? Your amount is not, your balance is not credited by the 200 rupees, but your friend account is debited by the 200 rupees. So this is what, at the time his friend account or database is okay, but your account database is not justified properly. So we have the two transition. What is the transition? One is credited, another is debited. So credit is debit is done perfectly, but credit is not. Vice versa can be. Credit is done perfectly, but debit is not perfectly. So here the both transaction should be complete properly and followed by the one property, and that is known as the isolation. So I'm speaking once again to all. If you're looking for the perfect transition or good transition, that it must have the acid property, and that belong to the atomicity, consistency, isolation, and durability. So if you want to implement the isolation proper way, then the concurrency education we have, because we are moving one transition and the transition, then it must have the consistent state like this one. I'm just coming back to this one. Now see, in this example, we have the consistent state. Now this is a concurrent education example, is a good example, there's no issue. So now we can say the isolation is maintaining by the this schedule. Okay, or we can say the transition T1 and T5. So this is my point. If we don't have if a transition is failure again and again, and to avoid such thing, because transition cost is very high, so it is a better idea to maintain such thing. So we have the important concept over here, and that is known as the concurrency control scheme, and that we can use to ensure that even when the multiple transactions are executed concurrently. Concurrently means one transaction and then switch to the another transaction. Parallel or simultaneously cannot be possible, and only acceptable schedules are generated regardless of how the operating system time sharing resource such as the CPU time among the transition. You can understand this concept like the round robin algorithm. So in the round robin algorithm, what we have seen the operating system, we assign the time followed by the time quantum to each and every process. If the one process time is just ended, and then another process is ready to execute because other process has to wait. But a process which requires a long time, then other processes waiting time will be high. And to avoid the such thing, so we use the proper CPU utilization by providing the time slice or time quantum to each and every process in the round robin algorithm. Same thing we can apply. Same thing we can apply. So this can be done here by taking the our concept that is known as the concurrency control scheme. So before understanding the concurrency control scheme, we should understand what was the drawback, and that is required to understand the concurrency control scheme. So here I'm reading the some few points. That is trivial example you can take over here. So right now I'm skipping this slide because theoretically you can read out. Here we have the two different operations. Those belong to the concurrency control management. So I'm coming on that point. But before coming on that point, let me know more detail about the concurrency control. Okay, so if we're talking about the concurrency control,